In this video, we're going to talk about DHCP, and everybody loves DHCP. DHCP itself is actually a very relatively common protocol that you're going to be using in the environment. It stands for Dynamic Host Configuration Protocol, and what it allows you to do is to dynamically set IP addressing information, default gateway, subnet mask, TFTP server, DNS server, other various information, maybe like a TFTP server if you're dealing with voice over IP and things like that. But it allows you to set the IP addressing information dynamically, so you don't have to go to individual computers, set the IP addressing information on an individual basis. So you may have, for the guys that have been doing this for a while, and I'm not saying just guys as in men, but anyone that's been in the industry for a long time would know what they refer to, or would know what I mean when I refer to sneaker net. And there's actually no network; it's you physically having to walk around and do it. DHCP pretty much did away with that concept. And what I'm going to do here, I'm going to show you a couple different ways to set this up. I'm going to make sure that router 1 and router 6 each get an IP address. Router 6 is going to get a specific IP. We want to make sure he always gets the same IP address every time. And we're also going to set up so that router 7 is our default gateway. And we're going to make sure that in case the DHCP server, for whatever reason, router 7 failed, we would be able to go over to router 8 and get an IP address. So we'll talk about that as well. So there's three different ways you can set this up. Or there's two ways to set it up. There's three different roles and capabilities. You have the DHCP client, who is the device receiving the IP address, subnet mask, default gateway, and things like that. Although you'll find that when you're dealing with DHCP, a default gateway in some instances may not be applicable. So depending on the way you set up everything, if you are working with the client, you might have a dedicated DHCP server or a server that is handing out a scope of addresses for a subnet that doesn't actually have a default gateway. But I've never actually seen that done. But in order for an IP address to be a valid address, you have to have an IP address and a subnet mask. A default gateway is an optional additional configuration so that the devices on the network would be able to leave that network and go to another one. So that's just a capability that's out there that gives you that advantage. So what we're going to do here is we're going to talk about the client, which is going to be router 1 and 6, the server, which is going to be router 7, and then we're going to have the relay agent, which is going to be 7 pointing to 8. And 8 is also going to have the same information for 1 and 6, and we'll then turn off the DHCP server capability on 7 and show you what that looks like. And I might actually just do it the other way around, show you the relay and then show you the server so it's faster. So I'm not actually pulling any configuration out. I'll be actually speeding it up a little bit. So the idea with the client, we'll start with 1. And on 1, we will go to, I'm actually going to type in UAll, which is going to be turning all the bugs off. I'm going to go to global config, I'm going to type interface ethernet 1/0. I'm going to type in IP address is DHCP. Okay, that's going to cause our connections to go down. I'm also going to go to router 6 and do the same thing. Interface ethernet 1/0. Type in IP address is DHCP, but I'm going to add in an additional line of config, which is the client ID is going to be ethernet 1/0. The client ID is going to allow you to send the client ID, and I'll show you how to pull that in here in a minute. He's going to send the client ID up to the DHCP server or relay. He's going to look at that, forward that information over to the relay or the server, depending on the situation. And the client ID is going to be mapped to a specific host IP address. So this is how you would manually set the IP address on a router via the client ID. So basically this is the same thing inside of Windows DHCP servers where you set the reservation. So the idea is that when the DHCP server sees the MAC address of the requesting device, it has a reservation set up so it always receives a certain IP address. So we'll do that. So now what I'm going to do is I'm going to go to router 7, and I'm going to go and I'm going to say underneath the interface of Ethernet 1/0, I'm going to type in IP helper address is going to be 87.0.0.1. And so I type in do ping 87.0.0.1. That is the address, right? Do show IP interface brief 87.8. That would explain it. And we're going to say IP helper address is .8. So now what we're going to do is we're going to say on 8, we're going to exit out of here, We're going to type in DHCP, or sorry, IP DHCP, and we're going to say dash pool, or no, sorry, pool is going to be CCNP CID, or client ID. We're going to type in the, we're going to go to router 6 and type in do show interface Ethernet 1/0. I'm going to take this information right here. This is the burned in address, or the BIA. This is the MAC address. Take this guy. I'll type in the client identifier. ID is going to be this guy. But what I'm going to do is I'm going to pull all these dots out of here. I'm going to pull these out. I'm going to type it as 01. The 01 indicates that it's either Ethernet or wireless. I'm going to count over 2 spaces and put a dot in there. Count over 4 more spaces. So 1, 2, 3, 4. And this is going to be my 4 spot. And in between the 1 and the C, or the 0 and the 1, I'm going to put another one. I'll type in host is going to be 10.1.100.6. The default gateway, or the default router, will be, and this is one of those times where a default router might not necessarily be needed, but I'm going to type in a default router of 10.1.100.7. That'll be the default gateway, and the DNS server will be 10.1.100.7 as well. So now I come over to router 6, and it says OSPF is basically saying there's no IP address for that interface. That's okay. That's completely okay. And we're going to go back to 8, and we're going to go and exit out of here. We're type in IP DHCP pool. We're going to say CCNP. We're going to type in network of 10.1.100.0. And we're going to say a 0.0.0.255. Right, that's what I thought. 255.255.255.0. We're going to type in the default router will be 10.1.100.7. The DNS server will be the same. And then we're going to say, I think that's all we need to do. And that's all we have to do there. So what we're going to do is we're going to go to router 6. And what should end up happening here is if we were to go exit out of here, or actually I should say interface Ethernet 1/0, and type in shut the interface down, and type in no shut, we should actually signal out that we need an IP address to router, to OSPF, or to the DHCP server. So show IP DHCP binding. What's got it? Hold on a second. Let's do a ping 10.1.100.7. I can talk to it. Did one get an address? Yes, one got an address. Why didn't 6? Do show debug. No debugging. Oh, that's IP. That's OSPF for you though. Do show IP. Do show run. interface Ethernet 1/0. Why is that not coming up? It should be receiving an address. And here on 8, you can see that it received an address. So 1 got an address, and we see that by looking here at do show IP interface brief. We see that right here, and it received an IP address via DHCP. So I don't know why this isn't working for router 6. If I exit out of here and type in, or let's go to 7. I'm sorry. We'll exit out of here. We'll type in IP DHCP pool is going to be CCNP_CID. Type in host of 10.1.100.6, and then the client ID identifier is going to be, and we're going to put the 01 in front of that, 01 dot, pull that guy out, that in there, oh no, too far, dot, and another dot there, nope, one more. I don't know why that's not working. Do show IP interface brief. Let's see here. 7 do show IP DHCP bind. This one's going to show up oh, that's our problem. No, sorry, it doesn't even see it. And see, you can see here, it says relay here for this guy. Oh, you know what? I had to type in default router of 10.1.100.7. Maybe that would help. It is seriously not liking that command. Did that get an address? Nope, it sure didn't get an address yet. We go to 7 to turn the relay off. Go to interface Ethernet 1/0 and type in no IP helper. Shut it down and no shut it. The client identifier is supposed to be an advancement here, but I don't know why it's not working. The funny thing about it is the first video I shot for this. Oh, see now, this guy. Oh no, it didn't. Not for. One shows up. This is still a relay though. So we're gonna go to exit out here and type in IP DHCP pool of CCNP. We'll say that exit IP DHCP pool for CCNP-CID is no. There we go. So now 6 should receive an address. Let's make sure 7 do show run interface Ethernet 1/0. The helper address is gone. So now 6 should receive an address. Do show run interface Ethernet 1/0. No, pull this guy out of here because we're not going against the client ID anymore. We're type in IP address is DHCP. Now we should be able to get an address, just regular DHCP now. Sometimes these routers can just be finicky. There's been several times where I've been able to do this labbing, and it's worked just fine, and I don't know why. It could just be the fact that they've been going for a few days. I don't know why it's not doing that, so we'll just shut them down. It should automatically pick it up an address, and then no shut it. Because what we have now, and the reason why it works the way that it does, is when you're on router 7, when you have a when the initial discover packet goes out. So if you guys don't know how DHCP works, there's a discover packet that goes out that's in all 255's broadcast. That goes out to the server, out onto the LAN to find out an address. If there is a DHCP server local to your LAN, it will respond because it's listening to port 67. 67 is a server, 68 is a client. So it sends out the information on 67, and then 68's listening. That's called a boot P protocol. So what ends up happening then is you get an offer, DORA. So you get a response back in here. Now this one's broadcast. This one here is unicast. The offer comes back in with, you know, an IP address of whatever and / whatever, and then any additional information that comes along with that. You have the request that goes back out that's also unicast, and he's saying, I want to know that I want that IP address. Please give it to me. You also get an acknowledgement back in towards the router or to the device receiving it that's also unicast and says, okay, now you have that address, and here's the amount of time you have it for. Now, if you're using relay, it's done the exact same thing. You know, you have your discover broadcast, but instead of stopping here on this guy, it is actually flipped from a broadcast to a unicast out to the DHCP server, and then the communication from the server to the client is unicast. For the offer, you have a request that goes back out, which is also unicast, and then you have the acknowledgement that goes back in and says, okay, now you have the address. So just this guy just provides the data plane connectivity for that. So let's see if we're back up and running now. And we still haven't got an address. That's really blowing my mind. Let's say do show run interface Ethernet 1/0. Let's go to router 7 and do show run pipe section DHCP. And I might have to pull that other. Well, no, I've already pulled it out. So show run pipe section. Wait a minute, there's nothing in there. IP DHCP pool CCNP network of 10.100.0/24. The default router is 10.1.100.7. The DNS server is the same. And do show IP DHCP bind. There it goes. Now it's got an address. So I didn't get the address I wanted it to. Now I should be able to go in and create one, and that it should just pick up the .6 address by using the client ID. Because if you look on 7, we type in the bind. Here is the information. This is just the hexadecimal variation of this up here. So if we were to use this address and do a do show IP ARP, you'll see that .3, this is the MAC address. If we would have copied that in, that's the hardware address. If we copy that in, that should be what we'd be able to pull in. So I don't know why that wasn't working. I can't explain it. Sometimes there's just these GNS3 routers go goofy sometimes. But that's how DHCP works. There's some other options out there, like you can set the option, and I don't know what any of the options are off the top of my head. I'd have to look them up. Let's take a quick peek at. Let's see here. Let's see here. I'm going to do a quick Google search for DHCP options. Let's see what some of the options are. Oh, you know what? Here's the So let me bring this over to you and bring this in just a little bit so it's easier for you guys to read. So the idea here is if you have option name is, and I believe this would be option 1, subnet mask, you have 3 as a router, time server is 4, name server is 5, domain name server is 6, boot file size, host name. Those are just some of the different capabilities that are out there. So I don't know if there's a TFTP option in here. Let's see. And these give you all the information you need. Network time, NTP servers be 42. Let's see here. SMTP, NNTP, finger, IRC. Let's see. There's the client identifier. TFTP 66. So if you were to type in option 66, so let's try that. Let's type in do I have an options capability? Option, and we'd be able to specify option 66, and we'd be able to say IP, and you'd be able to type in the TFTP server. But you'd have to know the code in DHCP to be able to type that in. So we could say if there was a TFTP server, we'd be able to type that in and be able to, then it would get that information and then signal that for it. So that's basically how that would all break down. So that's pretty much what I wanted to cover in this video. I hope this has been informative for you, and I'd like to thank you for viewing.